Hey folks, Mrs. White here. Today we are practicing solving from 6.2 all period long, all time together now and into the practice that you're going to be doing. I'm going to try to make a reasonably quick video today. I do want to spend some time reviewing graphs again, and then we'll just talk about what your practice activity is, and you can use this time to be working on that. So that's what we're going to do, two exponential graphs. We'll go over a couple of the homework problems as we see fit, and then we'll do 3 problems from the actual homework sheet. So hopefully you saw the riddle sheet. It is online. If you would like to print it, you're welcome to. If not, please make sure you are just solving all of the problems. And there's more than like 10 problems here. There's a lot, but they start out easier and they get harder. So let's quickly review how do we go about graphing these exponential functions. I know they're exponential because my variable is in the exponent. This one is an exponential decay because it's a decimal value between 0 and 1. And this one's going to represent exponential growth because it has a growth factor that is greater than 1. So looking here, I'm going to first look, is there any plus or minus at the end? There is not, which means that I'm going to have an asymptote right here on the x-axis. Since this is exponential decay, it should follow this sort of form, right? Where it's steep and then it narrows off and starts approaching my asymptote. Sorry about that. So like always, I'm going to make an XY chart. I don't just choose x's willy-nilly. I'm going to take this exponent. I'm going to set it equal to -1. I'm going to take that same exponent. I'm going to set it equal to 0. And finally, I'm going to set it equal to +1. So I'm going to add 3, that gives me 2. I'm going to add 3, which gives me 3. And I'm going to add 3, which gives me 4. I'm going to go through this a little quicker because I want to make sure that this video is short and sweet, but still reviews what we need it to. So if I plug in 2 here, 2 minus 3 is -1. Anything to the -1 power means change the location. This is going to become 4. 4 times -2 is -8. So I'm going to go over +2 and then down 8. Now this graph does not go down 8, okay? So I'm going to make everything with a scale of 2. So I'm just going to mark that really quick. -2, -4. Okay, so I'm going to go over to 2 and I'm going to go down to 8. So -2, -4, -6, -8. I'm ready for my next one. I'm going to plug a 3 in here. So 3 minus 3 is 0. Anything to the 0 power is 1. So 1 times -2 is going to be -2. So at +3, which is right between 2 and 4, I'm going to go down to -2. And then my last point here, I'm going to plug in 4. 4 minus 3 is 1. So 1/4 is going to stay 1/4. So I'm going to go across the top and across the bottom. So I'm going to have -2 over 4, which is the same thing. -2 over 4 is -1/2. So I'm going to go over to 4 and down. Now remember, this is a scale of 2, right? So I'm not going to actually go half a box. I'm going to go down 1/4 of a box because halfway down the box would be 1. So 0.5 is going to be like right here. So here's the general trend of our line. Ooh, and it's going to get really, really close to that asymptote. Now, you might be like, Mrs. White, I thought it was going to go like this. Well, it is going like that, but remember, when we multiply by a negative on the outside of any equation, it always flips it. And this happened to flip it over the x, so it's kind of upside down. Okay, and there's our function. Let's take a look over here. I'm going to make an XY chart again. This one's a little bit more involved. I notice I have a -5, so my asymptote's going to be shifted down 5. So 1, 2, 3, 4, 5. This is exponential growth because my growth factor is larger than 1, so it should look something like this, going up, woo, like that, okay? So I'm going to take my exponent, x plus 4. I'm going to set it equal to -1. I'm going to set it equal to 0, and I'm going to set it equal to +1 because those are the easiest exponents to work with. So I'm going to -4 minus 4. I get -5. I'm going to -4 minus 4. I get -4. And then when I -4 minus 4, I get -3. And now I'm ready to plug those values in and see what I get. So if I plug a -5 here, I get -1. 3 to the -1 gives me 1/3. Okay, I'm going to move that 3 below. And 1/2 times 1/3 is going to be 1/6. So I currently have 1/6 minus 5, which is going to give me a -4 and 5/6. So pretty close to -5. So I'm going to go over 1, 2, 3, 4, 5, -5, and I'm going to go down 1, 2, 3, 4, and 5, 6 is really, really close, right about there. Now if I plug in -4, I get a 0 here. Anything to the 0 power means it's going to be 1. 1 times 1/2 is 1/2. So I technically have 1/2 minus 5. Well, if I'm at a half and I go backwards 5, I'm at negative 4.5. So I'm going to go to negative 4. I'm going to go down. There's negative 4.5 right about there. The last point I'm going to do is this negative 3. Negative 3 plus 4 is 1. 3 to the first power is just 3. So half of 3 is going to be 1.5. So I currently have 1.5 minus 5, which 1 minus 5, or I could think of like 2 minus 5 is negative 3, but I have a 0.5 there, so I'm actually going to be at negative 3.5. Okay, so I'm going to go over to negative 3. I'm going to go down 1, 2, 3, and half a box. So you can see, oh, there's my little trend right there. It's starting to increase. Okay, and it should hug that asymptote. Quick little review, your assessment that we're going to be taking next week is going to be just graphs and solving, okay? There might be a couple word problems too. So here's a picture of the homework that you folks did. I assume the fraction one was maybe a little tricky, so we'll take a look at this one. And then maybe we'll take a look over here because this one looks a mess too, and I think I would have to simplify both sides here. So we'll do these two problems, and then we'll move into talking about the activity you have to do for today. So when we're solving an exponential function, and I know these are exponential because they have the variable in the exponent, okay, I'm going to rewrite it with the same base. Now, neither of these bases are prime, so I need to prime factorize them. I know 9 is the same thing as 3 squared. I don't even need to make a factor tree for that. So I'm going to rewrite it as 3 squared raised to the 3c plus 1. I'm going to just simplify that right now. I know it's going to be 3 to the 6c. And then I'll send that 2 over here, plus 2. So this 27 can also be factored. I know what this is in my head, but again, I want it to be a base of 3, so I'm going to start by pulling out a 3. And I end up seeing 23 is the same thing as 3 to the third. But that's also going to be raised to the 3c minus 1. So I'm going to send this 3 here and rewrite it. 3 times 3 is 9c, and 3 times negative 1 is minus 3. So now because my bases are the same, cancel, cancel, I get 6c plus 2 equals 9c minus 3. I'm going to add these over here, and I'll get 15c. I'm going to add this 3 over here, and I get 5. Okay. And then I'm going to... Oh my goodness, I made a mistake. I'm going to minus, sorry, I was like, why is this not working? I'm going to minus 6c, and I'm going to get 3c. There we go. That looks better. Now I'm going to divide by 3, and there you see. There you see C. C equals 5/3. Boom. Shakalaka right there. Okay. Let's take a look at the one right next to it. I know you might think that you could just take this 16 and make it 8 squared, but I want to remind you, when we square something or square root something, it is not times 2. 8 times 2 is 16, not 8 times 8. 8 squared is actually 64. So what we should do here is prime factorization. Here we should maybe do some prime factorization also, okay? So right offhand, I know that 16 is 4 squared. But I can't make 8 a base of 4, okay? Because 8 can't be broken down into prime numbers that are 4 and 4. It's going to be a 2 with a 4. You can't do it. So I'm going to break everything down into 2's. So I know 8 is the same thing as 2 to the third power. We've done that a lot, so hopefully that's familiar to you too. And then 16, if I put it over here, is going to be 2 times 8, and 8 is 3 2's, right? So 16 is just 2 to the 4th power. And then that's going to be raised to the y plus 1. So I'm going to do my power to power rule. I have 2 to the 6y plus 12. And now I have 2 to the, I'm going to send my 4 here and here, 4y plus 4. I'm going to cancel my bases because, you know, if they're the same, I don't have to keep them. And I'm going to set exponent equal to exponent because if the bases are the same, then the exponents have to be the same. I'm going to minus 4, and I'll get 2y. I'm going to minus 12, and I'm going to get a negative 8. Last step, divide 2. Boom, y equals negative 4. So hopefully if you struggled on either of those two, it's some clarification, but it's also a nice little review of some problems that could be tricky. Your sheet that you're going to be doing for the rest of our time together and or your homework is going to have 21 problems on it. It's kind of nerdy. I did not make this sheet. I do have some nerdy sheets that I make, but this one I did just purchase offline. I thought it was good, and it's the exact type of problems we're working on. So you're going to answer this riddle. What did one wall say to the other? And it is not about figuring these numbers out right here and what the wall said to the other, okay? It's about you doing these 21 problems. Now, 21 is a lot. I get that. But I want to point out that some of these are really, really nice, okay? So let's start maybe by taking a look over here at 3. I hope you have the sheet in front of you. If not, it's kind of hard to read. It says 9 to the 2x minus 3 equals 9 squared. Now you might be saying, all right, those bases are not prime, so we need to prime factorize them. Well, stop. Both those bases are exactly the same. So in the first handful of problems, because the bases are the same, you just cancel them out. If they're the same bases, the exponents have to be the same. So really, the only work here you're doing is 2x minus 3 equals 2. So I'm going to add 3. I get 2x equals 5. I'm going to divide 2. I get x equals 5 halves. So I'm going to come over here. 5 halves as a decimal, because that's how they represented them here, is the same thing as 2.5. So everywhere that number 3 is, okay, right, because this is number 3, I'm going to put the letter E. So where's there 3? Where's there 3? Right here. I'm going to put an E right there. And that's it. There's no more 3's. Now I'm ready to go to the next problem, okay? So you're going to do that with all of these. The answer should all be down here. If for some reason you solve something and the answer isn't down here, that should be a red flag. You made a mistake, okay? So let's do one, maybe 2 more problems. Let's look at this one over here. They got a negative exponent, and then we'll do 17. So this problem is 4 to the negative 10 equals 16 to the 2x minus 2. Neither of these are prime. But I want to point something out to you. You could say 4 is the same thing as 2 squared and then do all of your 2's into the 16 and write it out that way. But I also know that 16 could be rewritten with a base of 4, right? If I have 4 to the negative 10, I just need them to have the same base. Well, 16 is the same thing as 4 squared to the 2x minus 2. So I could just do this instead. You're going to get the same answer as if you did it all the way through with 2's, okay? So since they have the same bases, they can cancel. Over here I have negative 10. I'm just going to send this 2 across right now. So 2 times 2x is 4x. 2 times minus 2 is minus 4. I'm going to add 4. I get negative 6 equals 4x. I'm going to divide 4. I end up getting that x equals negative 6 over 4, or negative 3 over 2, which is the same thing as negative 1.5, right? Top divided by bottom. So I'm going to look down here. Negative 1.5 is right here. It's going to be the letter U, and this was also the number 15. So everywhere that I see a 15 down in my sentence, I'm going to put a U. So 15 is going to be U, and that's it. Okay? And I'm done with that one. Okay? Let's take a look. So we did one that had this negative power. It didn't even matter, right? I don't do anything with it. I just get my bases the same. Now, this one's tricky, okay? I want to be very, very clear with you, and that's why we're going to do it together, okay? So if I take a look, I have a fractional base, and then I have 2. Now, 2 is prime, and 1/2, well, I mean, it's a decimal already, so it's kind of prime, right? But there's a relationship between this 1/2 and this 2. I want you to think about, what could we do to this 2? What power could we raise it to that would move the 2 into the denominator, and then you need a 1 for the placeholder? Hopefully you're thinking, oh, if this was a negative power, right? If this 2 had a negative 1, it would become 1/2. So you can show that, and that's right, okay? You can show that 2 ways. I could rewrite 1/2 as a base 2 to the negative 1, right? Because 2 to the negative 1 is the exact same thing as 1/2. Raised to the 4x, because that's what they have going on there, equals 2 to the 2x plus 6. I could also rewrite this with a negative here and change it to the 1/2. So I could have 1/2 with a negative, but I like the 2 better. It feels nicer to avoid those fractions. So I'm going to send the negative 1 here, and I'm going to cancel my bases. So I have negative 4x equals 2x plus 6. So I'm going to add 4, minus 6, minus 6. So I have a negative 6 equals 6x. I end up with x equals negative 1. So I'm going to come down here, try to find a negative 1 right there. So I'm going to put r where the 17 is below. 17 right here. Okay? And I'm ready to keep going. So I already gave you a head start. There are 21 problems. I just did 3. So what, you're left with 18, okay? Which is a little bit more manageable, but you can see a lot of these are going to go very, very, very fast, okay? So take your time, do your best. Please show your work as much as I did in each of these problems. If you can just cross off here and here and then set it equal, then go for that. Okay, but I am going to want to see some work for each of these problems along with the answer at the very bottom. If you don't have a printer, feel free to do it on Scrap. Hopefully this video was nice and short, giving you plenty of time to get working on this on your own so that you don't have a bunch of homework. When we get together on Monday, we're going to do a quick review video, and then when you're ready, you'll be taking your final quiz for the rest of the year, and you'll be done Algebra 2. You folks have done great. I know remote learning's been tricky, but we have about a week left, so you're doing a great job. Okay, let's keep it up and end strong. Thank you, folks. Have a nice afternoon.